Good morning, ladies and gentlemen. John Belkowitz, David W. Harris, Intelligent Concrete, where we make concrete do the impossible. We are commenting, reacting, I guess, to a photo that we get from some of our viewers. And this is the last one that we did was fun because either was beefing up of an older structure or correction of a failed structure. Something to that effect.
Yeah.
This one's a little bit more positive, a little bit more uplifting. It's it's a field of columns.
It's a forest.
It's a forest of columns. I tell you something. It's really quite beautiful to look at. And for my kids who are taking this CE 490 or 484 class at Stevens Institute of Technology, I mean, this is what we've been going over here, and to describe it to you. What is it, about, I don't know, 20 plus columns, and they've got more that they're constructing, and each column has its own isolated square foundation. It could be a square, it's just an isolated footing, and that isolated footing in the column, it's very important for building some of these beefier structures, superstructures or parking garages, because what we get is a load transfer from the structure to the foundation, and at that point where the foundation and the column intersects, you have this concentration of forces, which ultimately can lead to a singularity or punching shear, and that's because we have a triaxial state. David, do you want to go into that a little bit?
Triaxial state, sure. Say in the lab when we test a cylinder, that's uniaxial. We have a cylinder that has load in only one direction. But in the slab itself, we can have forces in two other directions. So that would be uniaxial, biaxial, triaxial. So we can get a triaxial state in the concrete, which has a tendency to strengthen it.
But also, it does increase the load, and that's why we oftentimes, because of that singularity, have punching shear, where the transfer of load goes from the column to the footing.
Correct. That can easily create punching shear. It's just like driving a nail through a board. It just pushes it right through.
And so for that, there's a section in ACI 318. In the old section, I believe it was Chapter 8. In the new -14, I don't know what section it is. But that's where we include shear reinforcement to protect from that, because as we know, concrete is fairly brittle. Standard concrete, whether it's 3,500 or 6,500, it's just not designed to deal with tensile loads and shear loads.
Correct.
So we have to use that secondary material for the composite structure, which is our reinforcing steel. And here it seems like you can kind of see in the distance, we're going to be posting this photo too, you can kind of see where they have some reinforcement set up for the future columns that they're going to be placing in that reinforcement cage, and it looks like either number 4 bars or number 5 bars put together with some stirrups. I can't see
it's hard
too
to
clearly.
Tell.
Whatever it is, that's going to be the load transfer between the column and the foundation. And if I was to guess what this structure would be, I would say it's a parking garage.
Could easily be a parking garage.
Just a lot of freaking columns, man.
Yeah, could be some kind of some other kind of building. Hard to tell just by looking at it.
Whatever type of building it is, it's got to be a building that's requiring a lot of live load or dead load support, because those are some beefy columns. Right?
Yeah.
I mean, the reason why I'm saying that it could be a parking structure is that the columns are thin and there's a lot of them. And normally with parking garages, they're trying to maximize space. So they either do really beefy columns and only a few of them, or very skinny columns, like more slender columns, and they do a lot of them.
Yeah.
But you could be right. I mean, I've been wrong in the past.
Yeah. But I think what is interesting about this picture is it shows all the different stages. As John was pointing out, in the second bay from what we're looking from the foreground, you see the cages for the columns, and then in the columns you see the bends for the splices into the next level. In the foreground, you see the pit dug for the spread footing, and one to the left you don't see concrete, the one to the right's already got concrete poured in. So I think it's really interesting that it shows so many stages of construction all in one shot.
Why do you think they have these, over digs around each of the columns? That's something I was trying to figure out.
Yeah, I don't know. I'm curious about that as well, whether that's just going to be, if it is a parking garage, maybe that's a little bit of depth for the slab that's to come in for the parking garage itself. I'm not sure why it appears to be over excavated.
You think they're going to backfill, compact it, and throw a floor over it?
Could be. When we built rigid foundations in Texas, we would over excavate so that the weight we took out would help balance the weight that was coming. But this excavation doesn't look like it's deep enough for that. So I'm not sure what the over excavation is for.
It's interesting because it's like in a grid pattern. It's almost like they're going to do a mat foundation, right? Where they're over excavating where they're going to pour concrete into, and there is some steel coming out of this section, so they could be building another foundation on top of it, or beefing up the foundation. Maybe it was a shitty design.
Well, as you suggested, I think it could easily be a parking level of a building or something like that. So, maybe they're just building a little extra depth around those columns for when they make the next pour.
Yeah, I mean, no matter what's going on here, I think we both have to admit that this is a beautiful photo and definitely an interesting job site. Compared to the last one. Last one, I wouldn't want to be I would want to be on the team, but I would want to be on the recovery team of that one.
Now, we don't know yet. I mean, what's going to happen with that?
No, I'm just saying. Like, if for this one, I mean, this looks like somebody put a lot of thought into not only the construction of this or the engineering, the construction, but also the mapping the job site out for the critical path of construction.
Yeah, that's a good point.
You see that?
Yeah, I think that's a good point. And I think the other point about construction versus design, I mean, we need to take into account all the construction loads that are going to happen during construction. In a lot of cases, they can be worse than the actual finished structure. So it looks like they put a lot of thought into the construction sequence and possibly the construction loads that occur during the construction to make sure it's all safe and done right.
And nobody's driving over a foundation and causing unneeded bending stress, because that's something we've seen, especially with sidewalks, driveways, or just exterior slabs. Right. Somebody drives over it, and you have to think, your concrete, it's designed to smile whenever you load on top, it bends so it's smiling. Here.
It depends. A roof, you don't want to smile, you want the opposite.
Well, I was talking about a slab or a beam or something like that. We designed it to do this so that the top section is in compression and the bottom section is in tension. Right. So if somebody drives on it the wrong way, just drives over the edge, and they create this type of loading or bending moment, there's a chance that there's not enough steel in the compression zone.
Right. And
then you get boom, boom, crack, crack.
That's right.
Yeah. And it's always good to have one of these things handy so you can do those explanations.
Yeah. Designed by foam. Yeah.
Designed by foam. So anyway, I think that's it for today.
I think so, yeah. This was such an interesting picture. I want everybody to see it and get an idea of all the different stages and thinking out the construction of a project, not just designing the beams and columns.
I really just love the photo. It's like something that you need to put up on the wall with the skyline.
Yeah, it looks like the sun's rising. We're getting the dawn of this new structure. I mean, it's just almost poetry.
I think it is poetry.
It is poetry.
It is poetry. All right. Thank you very much for staying tuned to this new Coffee Talk episode. We'll be posting this with the picture. If you have any questions, shoot us a message on LinkedIn, Instagram, Facebook, whatever. Y'all have a great day. Go concrete. Beat asphalt.